Now, who'd have thought that we could spend 15 minutes talking about addition, subtraction, multiplication, division, exponents, and roots in a college environmental science class? Seriously, were you expecting that? Me neither. Alright, so two-dimensional shapes here. You see we have two dimensions. We have an x dimension, which is the right left dimension, and we have an up down dimension, which is the y dimension. And this is, you know, paper dimensions. It has these dimensions, or these shapes have length and width in a two-dimensional plane. They are a triangle with 3, 1, 2, 3 vertices and 1, 2, 3 sides. It's a polygon. Triangle 3. There are 3 different types of triangles. There are equilateral, where all the sides are the same. There are isosceles triangles, where 2 sides are the same and 1 is different. And there are scalene triangles, which are... It kind of looks isosceles, doesn't it? There. Is that better? Sort of? No, that still looks isosceles. I cannot, for the life of me, draw a scalene triangle. I can do it like this. If this is a right angle here, boom. Oh, stop playing with me. There we go. Then each line here and each angle are going to be different. How about that? So that's a triangle. No problem, no problem. Rectangles are quadrilateral with 4 right angles. Count them. 1, 2, 3, 4 right angles. Squares are equilateral triangles, so that all the sides are exactly the same. Of course, all the angles are the same because they're all 90 degrees. So squares are rectangles. Squares are rectangles. But rectangles are not necessarily squares. This is a rectangle and a square. This is just a rectangle. Got it? Good. Circle is a closed curve that is equidistant from a center. So if this is the dead center here, which is, it doesn't look like it's very close to being center, but this distance is the same as this distance, which is the same as this distance, which is the same as this distance, and all the way around. The distance across from one side of the circle to the other is your diameter. The distance from the point to the outside is going to be a radius. Diameter goes across, radius goes halfway through. Got it? Good. And this would be a tangent line, and this would be an intersecting line, but don't worry about that. Just diameter, radius. Got it? Good. Perimeter is the distance around a two-dimensional shape. So a triangle, distance is really easy. Side plus side plus side. If this triangle is 3 plus 3 plus 3, then the perimeter equals 9, right? 3 plus 3 is 6 plus 3 is 9. Rectangle, side plus side plus side plus side. So this is 6, and this is, actually let's do this. This is 2, this is 6. 6 plus 2 plus 2 plus 6. 12 plus 2 is 16. So this one would have a perimeter of 16. Circle is a little bit different here. See this little symbol right here? That is pi. That's the same thing as saying 22/7, because there are 360 degrees in a circle. You can divide that out into pi, which is 22/7 or 3.14. Let me get this. 22 divided by 7, 3.14285571 forever and ever and ever and ever and ever. That's one of those numbers that goes on forever. So if we have a circle and the diameter is 12, then 12 times the diameter, 12 times pi is, according to my calculator, the perimeter here is 37.714,285, which is going to bring up the question for some of you. Where should you drop the decimal point, or at what point should you stop doing the decimal? There are rules that tell you what to do, when to round up, that sort of stuff. But as a general rule of thumb in this class, hold on to all the numbers until the very end, and when you get to the very end, round to the 10th. So 37.714 is going to equal 37.7. Got it? Good. But you haven't had this many difficulties yet, have you? I mean, you're doing pretty good? Good. The amount of space inside a shape is called the area. So if we have a triangle, the amount of space inside here, in the two-dimensional plane, is called the area. The formula here is area equals 1/2 base times height. So what you got to do is you got to figure out what the base is here. In this case, let's say it's 6, and the height here is 3. So area equals 1/2 times 6 times 3, right? 6 times 3 is 18 divided by 2, right? 6 times 3 is 18? Yes. Divided that by 2 is going to be an easy 9. The other way we could have done that is if you wanted to, you could go ahead and divide 2 out. 2 divided by 2 is 1. 6 divided by 2 is 3. 1 times 3 times 3 is 9. 1 times 1 times 1 is 1. Same thing, 9 over 1 is the same thing as 9. See? Bam! See how easy this stuff is? And you guys were worried. The rectangle, the area is length times width, so going back to, I did the same thing again. Going back to our rectangle here, 6 times 2 equals 12. For a circle, the amount of area, what did I say our diameter was for our circle back here? Come on, here, circle. Our diameter is 12. So we can do pi, 7 point, first we got to do diameter squared. So 12 times 12 is 144, right? Yes, and then we multiply that times pi, which is 3.14. That gives us 452.16. I said round to the 10th, so 452.2. What if we use this other formula? Let's see. Pi is 3.14, radius is 6. So 6 squared is, 6 times 6 is 36, times 3.14. I'm hoping we get, no. There's something wrong with my formulas here. Well, when in doubt, check your handy dandy formula sheet, which I have somewhere in my thing here. I'm not sure about, hold on, let me find my formula. My ABC formula sheet, which you should be able to find, you've probably got it printed somewhere right there. I see what I did. Okay, never mind. This is pi diameter square, so not pi diameter square, 0.7854 diameter square. So 144 times 0.7854 equals 113. That's way, oh. Come on back, come on back, come on, there you go. But I forgot to, stop. What I forgot to do, obviously, is turn on my pen again. We are experiencing technical difficulties. There we go, get. Alright, let's do this right. circle? 12. So pi r squared is going to be 3.14 times 6 squared, which is 36 times 3.14, which is 36 times 3.14 equals 113.04. Or we can say 0.7854 diameter squared, which is 12 squared, which equals 144 times 0.7854. 144 times 0.7854 is going to give us 113.09. So the difference here, 113.0 versus 113.1, not a significant difference. It just has to do with where we rounded and that sort of stuff. Okay. Don't you feel better now that we've gotten that off of our chest? I sure do. Three-dimensional shapes. Cones are essentially a triangle. You see the triangle right here with a circle. Volume for a cone is 1/3 times base times height for all cones. It doesn't matter whether they're right cones or not. But what we're going to run across most in the environmental field are right circular cones, which is what you see here. This is a right angle. Let's see if I can erase some of this stuff. Now, go back to my felt tip pen. If this is a right angle right there, then the formula here is going to be 1/3 pi r squared h. And we'll use these. So, and again, they're on your ABC formula conversion table that was at the very beginning of this lesson. Cubes are rectangles plus rectangles plus rectangles. So you got lots of rectangles. The volume here is length times width times height. Because I forgot to say that for here we've got a third dimension here. So we have the x dimension, the y dimension, and now we've got the z dimension coming right back out at you. Length times width times height. Height. Spheres are just a series of circles within circles, concentric circles. It's a ball essentially. The volume here is 4/3 pi r cubed, or 1/6 pi diameter cubed. Why 1/6 versus 4/3? Well, if you're using the radius, it's 4/3. If you use diameter, it's 1/6. But it's an easy conversion. The diameter is twice the radius, or the radius is half the diameter. However you want to look at it. For a cylinder, which is a circle wrapped in a rectangle, your volume is going to be pi times the radius of the circle squared times the height, because it's essentially this is the volume of the area of the circle plus the area of the rectangle in 3 dimensions. Surface area of the 3D shape, if it were flattened into 2 dimensions, is the surface area. So a flattened out cone would look something like this, with the triangle wrapped around it. A cube would have something like this if it were flattened out, like you flattened out a box. A sphere, a cylinder would be more like this. Not very good 3-dimensional shapes, but if you can imagine unrolling a Coke can, that's what it would look like. Alright, some basic algebra. And I think I'm getting pretty doggone close to the 15-minute mark. So I'm going to stop here, and when we come back, we'll do some basic algebra, and then we'll go through and look at a problem-solving process, and then I promise you, you'll get to do some math. I know you're excited and you really want to get to the math, but I want to show you that you guys can do all this stuff, and hopefully you're getting this. So I'll see you next time.